Hello everybody, today we are going to learn about options. And in this video, these are the things that I'm going to be covering, so sit tight and watch the whole video for you to learn something new and useful. Let's start with some definitions. An option is a financial derivative that gives the holder of the option the right but not the obligation to buy or sell a specific quantity of a specified underlying asset at a specified price, also known as the strike price, on or before a specified date, which is also referred to as the maturity date. Take note that while the holder is not obligated to exercise the option, the writer of the option is obligated to buy or sell the underlying asset at the specified price and date should the holder decide to exercise the option. But what does the term exercise mean? Exercise is the option holder's act of paying the strike price to the writer to buy or sell the underlying asset. Option premium or option price is the amount the holder needs to pay to the writer upfront to purchase the option. Take note, unless stated otherwise, all option prices are based on 1 unit of the underlying asset. And in the market, particularly the US market, options are always traded in the lot of 100 options. So you cannot just buy one option. Whenever you go to buy the option, you have to buy 100 options in one transaction. The definition of an option and all the other jargons that we learned in the previous slide are really long and heavy. And there are a lot of tiny little terms that we need to take note of. So let's take the help of a scenario to help us understand all these terms better. Meet Adam. He needs to buy 100 kgs of strawberries for a huge party in a month's time. However, he predicts that the cost of strawberries will rise from $8 per kg to $10 per kg in the next 1 month. Hence, it would be better if he could secure his order while the prices of strawberries are still cheap. He approaches Joe and requests the right to buy 100 kg of strawberries in a month's time based on the current strawberry prices. Joe agrees to sell the strawberries at $8 per kg, which is the current rate, provided that he pays an additional $1 per kg of upfront payment. Adam pays Joe $100, $1 for each kg of strawberry that he is going to purchase, and makes the deal with Joe, which gives him the right but not the obligation to buy 100 kgs of strawberries from Joe at $800 in a month's time. In this scenario, since Adam has the right to buy, he is the holder of the option, and Joe would be the writer. The specific quantity, underlying asset, and price would be 100 kgs of strawberries at $8 per kg. The maturity date is in a month, and the option premium is $1, assuming that 1 kg of strawberries is equivalent to 1 unit of the option. After a month, as Adam predicted, the strawberry prices have indeed risen to $10 per kg. So Adam approaches Joe and gives him the $800 in exchange for 100 kgs of strawberries as per their prior agreement. This way, Adam only pays $8 per kg for the strawberries plus $1 per kg as the fees for buying the strawberry option from Joe, and thus he manages to save $1 per kg of strawberry. In total, he is in profit of $100 from this entire transaction. In this scenario, you notice that Adam exercised his right exactly after a month. Similarly, in the market, there exist options where you can only exercise the option on the maturity date. These options are known as European options. There are also American options. American options can be exercised anytime before the maturity date. Take note, unless stated otherwise, all options in this video are assumed to be European options. Now, instead of looking at a fictitious scenario, let's take a look at a real option taken from Yahoo Finance and pick out all the relevant information. We know that the underlying asset of this option is Apple shares. The maturity date is in July 2025, and the strike price is $210. The option premium is $2.87. Take note that this value is for per unit of the option. If we are talking about the US market, options are always sold in the lot of 100 options. So when you go to buy this option, you will be required to buy 100 of them. So the total price of that transaction would be 2.87 multiplied by 100. One more important thing to take note of is that this is a call option. We'll talk more about what this means in the next few slides. There are two different kinds of options in the market: call options and put options. For each of these options, you can either be in the long position, meaning that you're the one buying the option, or you can be in the short position, meaning that you're the one selling the option. So naturally, with two different kinds of options and two different positions that you can take for the options, we will have four different combinations of positions altogether. In the next slide, we will go through each of these combinations individually. Recall that if you buy an option, you are the option holder, so you have the right to either buy or sell the underlying. If you sell an option, you are the option writer, so you have an obligation to buy or sell should the option holder decide to exercise the option. Here are the four different combinations. Let's go through them individually. So if you buy, immediately you will have the right. If you buy a call option, you have the right to buy the underlying at strike price. If you buy a put option, you have the right to sell the underlying at strike price. Now, if you are the seller of a call option, the person that you're selling to would be the option holder, right? So he would have the right to buy the underlying. So as a seller, you will be obligated to sell the underlying if the option is exercised by him. Conversely, if you are selling a put option, the option holder has the right to sell. So as a seller of the put option, you are obligated to buy from him should he exercise his option. So as option writers, we don't have a lot of choice, but as option holders, we have the choice to either exercise an option or to not exercise the option. But how do you know if you should exercise an option? Well, as investors where money is concerned, we always want to make profit. And how do we do that? We buy low and sell high. If a call option allows you to buy an underlying at a price that is less than the market price, which happens when the market price is greater than the strike price, then effectively, if you exercise the call option, you can buy the asset for a low price and sell it for a higher price. This means that the option is in the money because you will make money if you exercise the option. And if ST is less than K, then conversely, the call option is out of the money. For a put option, you are in the money if ST is less than K, because in this case, you can sell your asset for a higher price via the option than if you were to sell it in the market directly. And you are out of the money in the opposite scenario, which is when ST is greater than K. As option holders, you should only exercise the option if it is in the money. And if it is not in the money, then you do not exercise the option, because then you are not following this buy low, sell high principle. So let's say that you have a long position in a call option, meaning that you are buying a call option, making you an option holder. Recall that this means that you have the right to buy the underlying asset at strike price, which is represented by K. At maturity date, if the market price of the underlying asset, which is represented by ST, is less than the strike price, you know that you can get your underlying asset at a cheaper price by simply buying it from the market compared to getting it via the option by paying the strike price. So in this case, you would not exercise the option. However, if the market price is greater than the strike price, it means that you can get the underlying asset for a cheaper price via the option, hence you can buy low. And once you have obtained the underlying asset, you can immediately sell the underlying asset in the market for ST, which is greater than what you originally bought the asset for. So essentially, you're buying low and selling high. In this case, your payoff would be ST minus K because you're buying the asset for K but selling it at ST. The value or payoff of a call option in the long position is thus the max of 0 and ST minus K. So when ST is less than K, you do not exercise your option, so the payoff is 0. However, the moment your ST is greater than K, you exercise your option and your payoff is ST minus K. Take note that the slope over here would be 1 because the gradient of this graph is 1. Also take note that your payoff is not your profit. Because remember, you had to pay an option premium to purchase this option in the first place. So the profit would be the payoff minus the value of the call option at the time of maturity. This is the graph of your profit from the option. Take note that this point where the graph intersects the x-axis is known as the break-even value. And for a call option in the long position, the break-even value is K plus the time value of the call option. If you have a long position in a put option, remember that you have the right to sell the underlying asset at a particular strike price. Now, as sellers, we always want to be able to sell as high as possible, right? So if your strike price is greater than the market price at maturity, you would exercise your option because that way you can sell your underlying asset via the option at a higher price than what you would have sold in the market alone. And in this case, the value of the option would be K minus ST. However, if the strike price is less than the market price, you would much rather sell your underlying asset in the market directly instead of via the option, since the market provides you with a higher rate. So you will not exercise the option in this case. As such, the payoff of a put option in the long position is the max of 0 and K minus ST. As long as the market price is less than your strike price, you would exercise the option and sell your underlying asset via the option. But when your market price is greater than your strike price, you would much rather sell it in the market, so you would not exercise the option. And the profit would be the payoff minus the cost of the put option at the time of maturity. Take note that in this case, the break-even occurs at K minus the time value of the put option. Now, if you have a short position in a call option, remember that you have an obligation to sell the underlying asset if the option holder exercises the option. Since the decision of the option holder controls your payoff, we must think from the option holder's perspective to analyze the payoff you would receive as the seller of the option. Since we know that this is a call option, the option holder will exercise the call option only if the market price is greater than the strike price. So when the market price is less than the strike price, he does not exercise the option and you do not sell your underlying asset. Thus, the payoff would be 0. When the market price is greater than the strike price, the option holder exercises the option, forcing you to sell the underlying asset, and thus the value of the option would be the negative of ST minus K. Negative because you're selling the underlying asset at a price that is lower than the market price, so you're incurring a loss. You could have sold your asset at market price, which is higher, but since you're obligated, you can only sell it at the strike price. So you're losing ST minus K. And hence the payoff of a call option in the short position is the negative of the max of 0 and ST minus K. However, since you received a premium when selling the call option, your total profit would be the payoff plus the value of the call option at the time of maturity. And take note that in this case, the break-even value is K plus the time value of the call option. And finally, if you have a short position in a put option, recall that you are a seller of the put option and thus you are obligated to buy the underlying asset if the option holder exercises the option. Once again, let's think in terms of the option holder's perspective. Since you are selling a put option, the option holder has the right to sell the underlying asset to you at strike price. From earlier slides, we know that the option holder will exercise the option only if the strike price is greater than the market price. So in this case, the value of the option for you as a seller would be the negative of K minus ST. because you could have bought the underlying asset at market price, which is lower. However, since you were obligated, you have to buy it at strike price, which is more expensive. So you're losing K minus ST. When the strike price is less than the market price, the option holder does not exercise the option, and so your payoff is 0. As such, the value of a put option in the short position is the negative of the max of 0 and K minus ST, and the profit is the following. You add the cost of the put option because once again, you are the one selling the option, so you receive the option premium. Take note that the break-even in this case would be K minus the time value of the put option premium. I have put all the profit diagrams onto one slide to highlight a few things. Firstly, you'll notice that the profit diagram for a buyer of an option and the seller of the same type of option is inverted along the x-axis. So, for a buyer of a call option, the graph is as follows, and for the seller of the call option, the graph is inverted along the x-axis. The same relation can be seen between the buyer and seller of the put option. It's inverted along the x-axis. Intuitively, this is because if you're in profit as a buyer, as a seller, naturally you would be in loss. Secondly, the graph between the puts and calls are reflected along the ST equals to K line. So you notice that for a long call and long put, the graph is reflected along this line. Same thing for a short call and short put. And thirdly, let's observe each of these graphs more closely. You'll notice that for a long call, you have limited loss and unlimited profit. So you're getting the best of both worlds. For a short call, however, you have unlimited loss and limited profit. That's the worst of both worlds. And finally, for a long put and short put, you have limited loss and limited profit. So while puts have low stakes, calls have really high stakes, and in particular, short call is really dangerous. Now, let's take a look at an example to deepen our understanding. A call option on a stock has a price of $100 and expires in 6 months. The risk-free rate is compounded continuously and the option premium is $9.50. Find the profit of the option holder when the stock price expiration is $105.95. Now, as an option holder of a call option, you have the right to buy the underlying asset at the strike price. And remember that you will only exercise your option if the market price is greater than the strike price. 105 is greater than the strike price, so the call option is exercised. Recall from earlier slides that the profit of a call option in the long position is given by this. Substitute all the necessary things into this expression and simplify it to obtain the final answer. 95 is less than the strike price, so the option is not exercised. As a result, your profit is simply the negative of the price of the call option at maturity date, which would be this. We know that the profit diagram of a call option in the long position takes the following shape, where this is the strike price, and the y-intercept is the time value of the option premium. And the break-even occurs at the strike price plus the time value of the option premium. And with that, we have come to the end of this video. Thank you for watching the entire video, and I hope you learned something new and useful.